Hi everyone, this is Scott with CyberScribe.org, and today we're going to be talking about an introduction to binary numbers as it relates to IP version 4 addressing. And you probably know there is an IPv6, and that is hexadecimal. We're not talking about that. We're talking about how we get this number here translated to the more human-readable format right there. So, how is this useful? Why would you want to learn binary numbers? Well, if you're doing system administration work, or if you aspire to that, or networking, you need to know binary, because this is how the computer knows what network addresses you're using, the host address, subnet masks. All of those networking things are based off of binary, so you need to be pretty familiar and comfortable with it. Let's see if we can get you started a little bit here. One thing you can do to follow along is you can, if you have a Windows system, go and open up your calculator and click View, and you have a Programmer section. And the two things we want to look at here are the bin and DEC. So this is decimal and this is binary. So we can convert between the decimal and binary numbers. And if I just put in a number and change it to binary. Okay, and you can play around with that. It'll give you a pretty good idea about how these things work. Okay, so binary is a base 2 number system. There's only ones and zeros in this. You only have two choices, ones and zeros. And decimal, what we're going to be converting it to, is a base 10 system. You have 10 choices, 0 through 9. So let's talk about IP addresses as they are translated into binary. Well, they're a 32-bit address. If you counted up all those ones and zeros, you're going to get 32. And those are bits, we call them. A 1 or a 0, that's a bit. And an IP address is 4 octets of 8 bits. 1, 2, 3. 4 octets separated by that period. And in each octet there's 8 bits. Now, when you're starting off with binary, what you want to do is make a table of the values of each place in the octet. So let's say this top line is the octet. Here, 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 here. Doesn't matter. And this is how we translate that octet into decimal. So you see these are all 2's. Well, it's a base 2. So you take 2 and you raise it to the power of the place. Now remember, this is with computers, and most computer things start with 0 and not 1. That's why you have 0 here and not 1. But if you do the math, 2 to the 0 is 1. 2 to the first is 2. 2 squared, 4. 2 cubed, 8. What's happening here? You're multiplying these, just multiplying each one by an additional 2. Now, just like if I had the number 4196. Okay, let's break this out. So let's say 4,000 and 100 and 90 and 6. Just as you see here, the bigger number is on the left side. You see that your 4,000, your place is to the left, and your smallest one is to the right. Well, same thing here. So that's why we start from this side, because you're reading it this way. You're reading from left to right, biggest to smallest, but you need to start to populate this from the smallest to the biggest. You can do it the other way, but that's just how I was taught. So what you're looking at down here, this is the decimal representation of this binary place. So you have 8 places, 1, 2, 3, 4, 5, 6, 7, 8. In each place, the value is different. Now let's take a look in the binary calculator. Okay, let's just say, do an easy one here. Let's say you see a binary number that's just that, 1, 1. This is your binary number. You can go to the calculator and you can say 1, 1. Binary. Let's go to decimal. 3. How did we get 3? Well, if you look, this is the binary number, remember, and this is the decimal value. Well, what is 2 plus 1? It's 3. And there you go. Now let's add another bit. And let's say 1, 1, 1. Now guess what this is going to be? 4 plus 2 plus 1. 7. Okay. Let's do 8. Remember, these are the binary bits, and each one that I add is the next place. That's why the numbers are getting bigger. So here we're going to add this. And we have 4 binaries. 1, 2, 3, 4. 15. Okay. Now let's add another bit. So the 16 value is what we're going to start with. Remember, these are the decimal equivalents of the binary places. So what is this going to be? 24, 28, 31. Now let's just do this. Let's say 31. And it should be 5 ones. There you go. 1, 2, 3, 4, 5. So that's how we get the numbers with binary. Is just doing 63 and that, changing it to decimal, 127. And if this is 127 and we're going to add one more bit, well, what are you going to do? You're going to take 127, we're going to add 128. Let's see what that is. Well, what is it? It's 255. 1, 2, 3, 4, 5, 6, 7, 8. Interestingly, and it's not a coincidence, what's the highest IP address you can have in one of these sections? 255. How did they get that? They got that because the highest binary number you can have is where all your bits are set. And if you add all of these up, and if you add all of these up, the decimal equivalents, you will get 255. All right? So one other thing to think about is zeros in binary. Well, zeros in binary are the same as a 0 in decimal. A 0 is 0. It means nothing. So if you have a binary number, okay, this is an octet, remember, 8 bits. Let's make it 8. All right, 8 bits. Well, you don't count the ones with zeros. So yes, it's in the 32 place, but you don't count it because it's a 0. You only count the ones where you have the 1 bit set. So what would this be? It would be 192. Now let's double check that and we will see 1, 2, 3, 4, 5, 6, 7, 8. 192. So the question I was originally thinking about was, what's the largest IP address for any single octet? Well, we already saw it's 255. It can be no bigger than 255 because all the bits are set. There's no more room. Okay? And let's do 2 more examples here and let's finish it up at that point. All right. Now this is an octet, right? Could be here, it could be here, here, or over here. Okay? Doesn't, at this point it doesn't matter. But what is this going to be? Well, it's going to be 128 because remember, 128 and the bit is set. And next is 64. Okay, now this is a 0, so because the bit is not set, we're not taking this number. So we're going to skip these because they're all zeros, we're not taking that number. Now this, the value is 2. So we're going to say 2. And this one, the value is 1. So we are going to say 1. Now, so what is this value here? Well, all you do is you add across. 128 plus 64 is 192. 194. 195. Okay, let's fill in these zeros and check on the calculator and make sure we did everything right. Alright, so we have 1 1 and then 4 zeros, 1 1. Let's do decimal, 195. Okay, do you see how we're getting that? This is the binary octet, the representation of these up here. Okay, and let's just do one more and we will finish it off. Now, a 0, and that's why you want to, if you have a worksheet or if you're doing this in a notebook or something, write down these often at the top of your paper because you'll use these very frequently. I still use them sometimes. So here, this is our next test octet. So this is going to be 0, right? The value of 0 is 0. Next one is going to be 64 because remember the bit is set and the value of that place is 64. Next one, 32. Remember, right there, right there. Okay, and because there is no bit set there and there, we put zeros. Here, what is the value here? 4. Remember, this is the decimal equivalent of these places in the binary. So this is going to be 4. And nothing here. And lastly, nothing here. So let's count this up. 64 plus 32 is 96. Plus 4 is 100. Let's see if I did that right. So we're going to say binary. Well, let's do decimal and just see how it works out. 100 to binary is, this is something you need to think about if you're using the calculator for this. It doesn't look right, but it is right. So let's look at it from this side. 1 1 0 0 1 0 0. You see, it left off this 0, the trailing 0. And that's what you have to watch out for if you're using the calculator, is that in IP addressing, you keep all the zeros. Even if the whole thing is zeros, you still keep it, because that's how the IP addresses and network addresses and masks and things are calculated. So you need to keep those zeros in, even if the calculator doesn't keep the 0 in. But 100, there you go. So that is a quick overview on binary and IP addressing and things like that. Hopefully it was helpful for you guys, and if you liked it, leave me some comments, subscribe, and I'm going to be making another video doing some more examples of how we get these numbers translated from decimal into binary.